Hello, today we'll be looking at the nuclear power station. This may be important to you if you become an engineer at one of these because you'll have to know how it works and especially the safety features involved. So this is a basic diagram of the features of a nuclear power station. Here we have the reactor. This is where the uranium nuclei undergo fission, releasing huge amounts of energy. This energy is carried by carbon dioxide molecules over here to heat up the water into steam, which flows into the generator, turns the turbine, and releases electricity. Here we have a cross-section of the reactor. This is the uranium, which is the nuclear fuel. Here we have the carbon dioxide, which collects the energy. And here we have a boron control rod. These are used to control the chain reaction by minimizing the number of neutrons flowing in the reactor. If there was an emergency, all the boron rods would be lowered, absorbing all of the neutrons and stopping the reaction. In grey here is the carbon moderator, which is used to slow down the neutrons, as only slow-moving neutrons will initiate a reaction. The neutrons are slowed down by collision with other particles. If it was to collide with a much larger particle, it would hardly slow down at all. If it was to collide with a particle of the same size, such as a hydrogen nucleus, it would be absorbed and they would move off together, or it would be stopped dead and the proton would move off at the neutron's original speed. What we want is this situation, where it collides with the particle and then moves off at a lower speed. So if we can't use a hydrogen nucleus, we have to use the next biggest thing. But helium is a gas, so we can't use that. Lithium is too reactive, beryllium is too expensive, boron absorbs neutrons, so we can't use that either. The next best thing is carbon, which happens to be what is used. Carbon also happens to be cheap and readily available. That's pretty much all you need to know about the nuclear reactor, and thank you for watching.